Hey friends, it's Devin here with Make Anything, and today I'm finally completing the Laser Trinity. That's because I've tested and compared several diode lasers and CO2 laser cutters throughout the years, but in this video, I'll share my first experience with a fiber laser in this 𝐒𝐓𝐋 Basic 1 20-watt laser marking machine. You know all those viral video clips of metal parts being magically zapped from an invisible source with a super satisfying noise? Oh yeah. Those are usually fiber lasers like this one, and they have to be the most unique out of these three technologies I've explored. So it may or may not be exactly what you're looking for, depending on your intended uses. Today, I'll cover all the pros, cons, and insights I've encountered with this technology, and this machine in particular, while marking metals, rocks, 3D prints, and more. So let's dive right in. Setting up this laser was pretty straightforward. The provided USB drive includes a PDF manual and video instructions, plus the laser really only has three main parts, along with some nice sample materials and a few other accessories. This 𝐒𝐓𝐋 Basic uses a galvo system, which involves a small but incredibly precise system of mirrors that redirects and scans the laser across the workspace. And that leads to very few moving parts and thus ease of use, plus it's very fast. So we just have this base that houses the actual laser, and that's fed through this fiber optic cable and up to the galvanometer up here, which redirects that laser. That leads to a system that's quite compact and portable, and it should also lead to less maintenance overall since all the movement is happening within this sealed system. The longest part of the setup for me was actually building the laser enclosure, which didn't come with as thorough of instructions. While optional, I definitely think it's worth having extra precautions near strong lasers, since their radiation can lead to eye and skin damage very quickly if not handled with respect. And I know myself well enough to know that I might take a quick, thoughtless peek over my laser safety glasses in the presence of an awesome laser. This enclosure filters out the harmful wavelengths of light so you can safely monitor the engraving process. With that fairly quick setup done, it was time to connect the laser to my computer. And this laser comes with a license for 𝐒𝐓𝐋, which is 𝐒𝐓𝐋's default software suggestion for this machine, but it's not compatible with my Mac OS laptop. So luckily, the machine has support for the popular Lightburn software as well. Lightburn will set you back a couple $100 for the Perpetual Pro license that supports galvo lasers, but it's a very powerful option that gives you a lot of fine control over your laser projects. Setting up Lightburn with the 𝐒𝐓𝐋 Basic 1 was pretty painless, with the ability to import the 𝐒𝐓𝐋 settings included on the USB drive, getting us quickly to this first test with the laser at just 1% power on some cardboard. This laser has the really awesome ability to trace a precise preview using a separate red laser, and that makes it so easy to line up parts. And just look at how great this is. No big gantry moving around, just a precisely directed laser beam. And a decent first test result as well. One thing we do control manually is the laser's focus, which is done by spinning this knob atop the stand. When these red dots line up, the laser should be properly focused. It's a bit clunky, but it's the price we pay, or rather don't pay, for a more affordable fiber laser. In any case, it does actually work quite well, despite feeling a bit unrefined. What you're seeing here is a coated aluminum tin I used to store my ground coffee, and after a couple of tests, I went forward with a larger graphic. With a few quick passes, I was able to get this really clean result. The base version of the 𝐒𝐓𝐋 Basic 1 includes this jig for placing round objects, and I was able to produce some nice tiny graphics on my water bottle, but I quickly discovered that this laser has a fairly small sweet spot for focus, and even slight changes in depth can drastically change the color and quality of the laser markings. So if you plan on marking a lot of rounded objects, it's probably worth upgrading to a machine with a rotary unit. Another good example of the variations caused by material height is shown in this flask. Stainless steel in particular is very sensitive to changes in focus, as well as the speed and power of the laser. And while I got a clear and dark engraving here, you can see a distinct change in color along the sides where the surface falls below the focus area of the laser beam. When it comes to marking metal surfaces, the variation caused by very slight changes in process settings can feel frustrating. For any new material or even material source, you'll probably need to run several tests to get the exact results you're looking for. And this machine, without the rotary unit, is really mostly suited for flat surfaces only. That said, these variations in marking can be super cool once you've harnessed that power. Check out the golden hue I got on this key, which then became much darker with additional passes. And compare that to this lighter mark made on the same machine just by increasing the speed and changing the focus of the laser. The ability to make the original metal surface both lighter or darker really impressed me, and by combining processes, there's a lot of potential to get fancy with your markings. Just running a few extra passes on one part of this Snell graphic gives me a really nice color separation. And on the back, here's another lighter mark. So versatile. And here's my awesome blossom on a painted shovel as well. I really like how well this laser works on coated metals. For a few more examples of marking on metal, here is some silverware that I labeled for ease of use, and this little warning sign I had to put on my kitchen scissors because Swedes like to snip their pizza with shears like insane people. Not in my house. Metal marking is definitely one of the strong suits of this fiber laser. The ability to handle completely reflective materials that would cause some other lasers to literally self-destruct is really impressive. But the thing I'm always most excited to try carving is rocks. Something about carving away at these hunks of minerals that have formed beneath the earth under insanely intense heat and pressure over millions of years, it makes me feel powerful. And to vaporize it with a laser, that's as close to alien technology as anything I've ever handled. So let's carve some rocks. I started off simple with this slate coaster that was included with the sample materials. The 𝐒𝐓𝐋 Smart Laser produced really clean lines. In this case, some of the thinnest details did disappear, and I've since learned that a second pass from a different scan angle would have helped bring those out. Still, the result is very nice and just slightly more crisp than the result from my 𝐒𝐓𝐋 S1 diode laser on the left here. That one does have a better contrast, but I think that's just the different coasters. Also, this super deep carving I did with the fiber laser would be difficult to reproduce with a diode. Here is that 40-watt diode laser 50 minutes in, and the engraving is nowhere near as deep as what the fiber laser did in half the time. So even if it is possible to do a deeper carving, it will take a much longer time. I just plucked this next rock from my yard, and while I don't know much about rocks, this one seems way harder than the coaster. So I was curious to see how it would fare under the laser. Pretty much all of these jobs were done at 100% laser power because why not? And sure enough, this rock proved to be a bit trickier. I let the engraving process repeat for 10 minutes, and here's what I got. Material has definitely been lasered away, but it's not quite as clean as the slate, and it barely went beneath the surface. I ran another process on the same rock for 40 minutes to see how much deeper I could get, and it certainly is a bit deeper, but there seems to be a diminishing return on this particular rock. By the way, laser blasting rocks does leave behind a lot of debris, so at this point I went ahead and designed and 3D printed this adapter for my X-Tool fume extractor so I could connect it to the EM Smart enclosure. That should at least collect the finest particles that end up in the air. And since the manual focus can be a bit slow and annoying, I also made this drill-mounted tool to raise and lower the focus much more quickly, which has been really handy, especially when working with a lot of parts of varying height. Anyways, back to the rocks. This red shale-type stone comes from an old alum mine across the street from my home, and it turned out to be pretty awesome for lasering. Here you can see the great contrast it produces quite quickly, and like the slate, it's a relatively soft rock, so while it is fairly fragile, it took only 20 minutes to get this super deep carving. Next, I decided to try drilling a hole by just repeatedly engraving a little 3mm circle at full power, and I managed to get through this rock in just under 5 minutes. That didn't quite scale well to this larger disc I tried to cut out, as it ended up taking 4 hours before I could just barely break out the inner circle. Well, that was a pretty time-consuming test. There's a reason this machine is called a laser marking machine rather than a laser cutter. While this galvo mechanism is super speedy, the fact that the laser source is beaming down from a stationary lens does mean that the laser generally isn't shooting straight down towards the part. And as such, it's not really designed for straight, deep cuts. I suppose the physics of the galvo laser is also why the focus distance is so shallow. You can really see that on this can, where the laser could only take the paint off the center inch or so of the can until I lowered the focus to try and clear the rest. But I was able to cut through this can in about a minute by raising and lowering that focus, so maybe something interesting can be done with that. But the rocks. I wasn't done with the rocks just yet. I really like the concept of engraving super clean and precise patterns onto a natural material like a rock. That contrast is just really fun and interesting to me. Here's a nice big piece I did, which involved 2 separate processes to go beyond the 110mm limit of the laser. It involved some perfect checkers and some waving lines. I think it looks cool. My process for these involves scanning the rocks using a regular flatbed scanner so I can create a design that matches the borders of a rock's flat face. Then I level the rock under the laser and line it up with my pattern using that super handy red laser preview. Then zippity zap, the laser does its thing. Also, you can adjust the laser focus while it's engraving to help it get a bit deeper. And while carving, it's easy to focus just by noticing how loud and bright the laser is marking. So here's the result, another very cool rock. I definitely did more of these rock carvings than justified for the sake of testing this machine, but they were just so satisfying. By the way, my ventilation system clearly misses a lot of the rock dust coming off of these parts, so I am hoping to create a better exhaust system soon that goes right up to the part to collect more of the debris. Otherwise, it's probably worth wearing a respirator if you plan on hanging out in the same room while this thing is lasering away. For my final rock carving, for now, I wanted to try out Lightburn's 3D sliced engraving setting, which goes over a provided grayscale image in multiple passes to achieve varying depths in one process, with black creating the deepest parts and white remaining untouched. I started with this simple pixel grid with varying shades of gray, and it started off looking okay, but the end result was pretty overcooked. Natural materials like this do tend to have a lot of inconsistencies, so I guess I'm better off with single depth engravings to get a clean result. But hey, I'm happy with these initial rock tests, and I'm excited to do more going forward. Besides rocks, I also did a test on this terracotta drip tray. That lasered really well, no complaints. And likewise for this glazed ceramic toothbrush holder from IKEA. This worked perfectly because it's got a thin black coat of glaze over white stoneware, so it was really easy to get a nice and bold image. In fact, any coated materials I tested produced some of the cleanest results. Here's a plastic chip clip with a thin metallic coat, and that worked really well. And these coated steel tweezers are clearly marked in under 5 seconds. So this laser might be powerful enough for commercial production of certain products. Up to now, I'd been throwing images onto objects without too much concern for absolute precision, but I did have some ideas in mind that would require accurate measurements, so I went ahead and made this calibration grid. The first thing that showed me was that the red laser preview was actually slightly smaller than the actual marking. Luckily, that was super easy to adjust within Lightburn. Up here, you can change the X and Y offsets and scale of that laser preview, and with just a tiny bit of tweaking, I got it to a point I'm happy with. At that point, I noticed this 100mm grid was coming out 2mm short. That's dealt with in a similar fashion in Lightburn with these Galvo configuration settings. For that, I just had to create a few different grids to fine-tune my results, and I'm just gonna let this clip run for a bit because I don't know about you, but I don't get tired of how satisfying this process looks. Anyways, fixing the scale did end up causing a more noticeable bulge on some of those straight edges, so I adjusted that within the same configurations just by doing some guessing and checking. The bulge adjustments affect both the Galvo and red laser preview, so I was able to test my adjustments against that preview with a straight edge until I had that pretty much spot on. Alright, with the laser all tuned up, I moved on to my next series of tests, which were all about marking on plastic. Since I primarily work with 3D printing, I was super curious to see how this laser handles various plastics, and these tests left me both super impressed and somewhat disappointed. As you'll see, the results were kind of all over the place. My very first plastic test was on this toothbrush, which is made of a mix of polypropylene and plant-based materials, and my first 2 attempts led to more melting than marking. Upon reducing the power to just 1%, I managed to get some color, but it was quite faint, and upon testing higher powers and multiple passes, I still couldn't get much brighter results. This earbud case also gave me decent results, not insanely vibrant, but certainly useful for certain applications. I was starting to feel a bit underwhelmed by the plastic marking, but this logo on my 𝐒𝐓𝐋 puzzle case made of printed carbon fiber PLA turned out brighter than the rest, and that brought my hopes up again. It was also interesting to note that the second pass darkened the mark, which is just further indication of how sensitive this material can be to slight changes in laser parameters. Next, I had my TPU printed phone case on hand, so I figured I'd try that, and I got a similar yellowish white coloration, which pops really well against the black background. At this point, I was thoroughly excited again, so I printed a new phone case just to try this idea of making a handy reference graphic for measuring lengths, angles, and radii on the go. I did have to switch from the standard sweeping fill process to outline fill, which instead follows the contours of the graphics in order to mark these small circles properly. And as you can see, I was just doing several low power passes to slowly bring out the color. Even with this careful approach, I ended up doing 1 pass too many and slightly burning some areas, but overall, I was super impressed and excited by how well this came out. I really didn't expect a laser to be able to turn a dark plastic so bright. With that encouraging result, I started testing a bunch of different PLA prints I had lying around, and well, the results were really all over the place. This blue Eco PLA only produced faint markings no matter how much I adjusted the laser settings, But then this green PLA gave me super bright marks. Then a different green would give me almost nothing, nothing from this red PLA, and so on, until I tried this matte black PLA from Bamboo Lab, and this was a clear winner. I could hardly believe how bright and detailed the markings were against this filament, and I excitedly put it to use with this sliding square puzzle I designed and printed specifically to use with the 𝐒𝐓𝐋 Smart Laser. Now, I only gave this one attempt, so I'm sure I could improve the brightness and contrast of the image a bit further, but I still think this cool giraffe came out incredibly well. It definitely won't be an easy puzzle to solve, but that's a problem for my 2-year-old nieces and nephews. Since this green Bamboo Lab PLA also gave me impressive results, I made a puzzle with that filament as well. The first pass was a bit light, so I tried to improve it with additional passes, and I may have slightly overdone it, but I still got a fairly good image and yet another nice, challenging puzzle. I will absolutely be playing around more with combining the fiber laser and my 3D prints. I was pleasantly surprised at how well certain filaments react under the laser, so that was great. Now, I have mentioned that a big advantage of this type of galvo laser system is the minimal maintenance. And with so few moving parts and an estimated 100,000 hour laser lifespan, there is certainly truth to that. But over the course of all these tests I've been sharing, I did already seem to notice the laser diminishing in strength. Because the materials, settings, and focus distance can make such a difference, it was hard to know if this was happening due to my own user error, a software issue, or the machine itself, and I ended up going back and forth with 𝐒𝐓𝐋 Smart's customer service quite a bit once I noticed certain jobs were requiring stronger laser settings. I first noticed problems with this steel coin while trying another 3D engraving. I had this thing going all day only to get a very shallow marking. Then on this next steel piece, I clearly noticed the laser fading in strength just after starting and seemingly getting weaker and weaker. 𝐒𝐓𝐋 Smart insisted that this wasn't a hardware issue, but more likely the laser being out of focus or a bug in light burn. I tried several adjustments with no improvements, and I had cleaned the outside of the lens, but at this point, I thought I would try cleaning the inside, even though it seemed like a totally enclosed system. Using 99% isopropyl alcohol and lint-free cleaning swabs and cloths, I carefully cleaned the internal galvo system and lens, and I actually did pick up a substantial amount of debris in there. So I guess it's not completely sealed after all, and that messy rock carving I did was probably the culprit. So again, I will definitely have to improve my dust extraction ASAP. The good news is that little bit of cleaning did seem to noticeably improve the power of my laser, and I was able to complete this very important label for my bidet holder. I also revisited the spider coin, and this time I used what I think is a brass coin. After 20 hours or so, I managed to get a really nice 3D effect, especially considering that the depth map was made in Photoshop without any actual 3D data. Now, I left the coin as is since I kind of like this aged look, but let me know in the comments if you think I should try polishing it to a shine. Also, yet another sign that I need better ventilation is that after this job, my whole garage was filled with magnetic dust, to the point where all the cobwebs turned orange. Probably not great. Now, I did mention the relatively small engraving size of this laser compared to the gantry-driven lasers I've tested before, but one neat trick with this laser is that the whole stand structure can be removed and rotated, which makes it possible to mark all sorts of larger items that wouldn't fit on top of the build surface. First, I tried this setup for my vice grip, which I could have marked normally, but I clamped it to a stepladder for the sake of testing this arrangement, and the laser was slightly out of focus at first, which caused a few defects, but once I had it set up correctly, the paint got zapped away and it looks really nice. After that, I lasered the ladder itself. I tattooed it with a big Snell the snail, adjusting the parameters and focus a bit for the shell to create both lighter and darker areas. Did my ladder need a snail? Probably not, but this is what happens when I get unrestrained access to a laser. This rotated laser assembly also means that I can mark my skateboard trucks without removing them, so why not another snail? And let's also throw a short snake on there for good measure. Okay, clearly I'm starting to run out of random ideas for things around the house to laser, for the time being. So let's start wrapping things up with some final thoughts and a few final examples of some things that maybe didn't work so well. First off, if you're trying to mark metal, this fiber laser is a clear winner of all the various machines I've tested. Blasting holes straight through stone is probably a less common demand, but that's something I couldn't do with my 40 to 50 watt diode and CO2 lasers. And I will say that wattage is one of those main features often listed on different lasers, but that value alone doesn't tell the whole story. I mean, a 40 watt fiber laser will probably be more powerful than a 20 watt fiber laser, yes, but man, lasers are just weird. And what mainly separates these different laser technologies nowadays is actually the wavelength of light that the laser produces. And it's been weirdly non-intuitive for me to wrap my head around. For example, I thought I'd laser a banana on the 𝐒𝐓𝐋 laser just for kicks. That's something I did 7 years ago with a 1 watt diode laser, no sweat. And yet, the fiber laser that carves rocks, zero effect on the banana. An orange? Pretty much nothing. Unsurprisingly, my Xtool S1 diode laser could handle those at just 5% power. Weird, but apparently that's the difference wavelength makes. And the fiber laser proved to be less effective on some other organic materials as well. For example, I thought cork should be pretty easy to handle, and while I could certainly burn the material, the fiber laser simply lacks the finesse that I can get out of the diode laser here. I faced a similar issue with bamboo on the fiber laser, where there seems to be a really tiny window between doing virtually nothing or sending it straight to the shadow realm. I'll also point out that I was able to carve this same red shale from before on the diode laser. It's probably 10 times slower, but the more lasers that can blast rocks, the better, I say. Also, the Xtool S1 is able to do some metal marking as well, and it was very clean, just nowhere near as visible and versatile as what comes off of the basic one. So that's the 𝐒𝐓𝐋 Basic 1 20 watt fiber laser. To summarize, the main pros are that it's especially great with metal, stone, and very specific plastics, and those other random things I showed you today. The Galvo system is crazy fast, and the whole process also just looks exceptionally awesome. Previewing your marking with that red laser is super handy and also very cool. And it's power efficient, it has a long lifespan, it requires relatively little maintenance, it's portable, albeit heavy, and the setup was also incredibly easy. Some downsides are how unpredictable it can be with new materials. Once you've got the settings right, it'll be great for batch engraving, but for guaranteed success, you'll pretty much always want to start with some extra material to test with first. At around $2,000, it's still pricey for a hobbyist, but the price for this kind of machine has certainly come down in recent years. The engraving area isn't very big, it's not really designed for cutting as much as marking, and I definitely need to add better dust extraction since it always just blasts away bits of whatever you're marking. Overall, I had a lot of fun playing with this machine, and I'm really happy to have it in my arsenal. I'm super excited to use it to add quick details to my 3D prints, and probably just to label and decorate every metal thing I ever get going forward. If you expect to be doing a lot of mid to large scale production work with the fiber laser, maybe you want to consider a higher wattage model just to get the job done even faster. But for the most basic model of fiber laser offered by 𝐒𝐓𝐋, this is already a very fine machine. And hopefully this video has helped inform you as to whether or not it's the kind of tool you're looking for. So that'll be it for today's video, but you can check out my laser video playlist to learn about all the other machines and projects I've tackled in the past. And of course, make sure you're subscribed to catch any future appearances from this laser and all sorts of other cool tech that is sure to come. Thank you so much for watching. You are very cool. Stay inspired.